Integrating this, it'll become 6x cubed over 3 plus c. So that will simplify to 2x cubed plus c, bounded by the points 2 and 4. We can ignore the plus c, as that won't make a difference to us as they cancel out. Substituting the points, so we'll have 2 lots of 4 cubed minus 2 lots of 2 cubed. Enter all of this into your calculator or work it out individually, which equals 112. This one, we've got this term, and this term. For x squared, it will integrate to x cubed over 3. Minus 2x will integrate to minus 2x squared over 2. And plus 4 will integrate to plus 4x plus c. All bounded by the points 1 and minus 1. Tidy this up a bit, so we'll have x cubed over 3 minus x squared plus 4x, bounded by the points 1 and minus 1. Substituting the points, 1 cubed over 3 minus 1 squared plus 4 lots of 1 minus 1 cubed over 3 minus 1 squared plus 4 lots of minus 1. Enter that into your calculator and you'll get 26 over 3, or 8.6 recurring. That's your final answer. For this one, we're going to use the table of derivatives. We need to find where sine x is, which is here, and that becomes cos x, but with the opposite sign. So we'll have minus cos of x plus c, bounded by the points pi and 0. Substituting those points, so we'll have minus cos pi minus cos of 0. Remember, for when you're integrating, you need to be using radians. You can either enter that into your calculator now, or if not, which equals 2. This one, we've got the two terms. If we integrate 10x to the 4, we'll have 10x to the 5 over 5 minus 8. Well, cos 2x, we've got k cos kx, that will integrate to a sine of the same sign, as in plus will stay plus, minus will stay minus, so 8 sine 2x, and then divided by the coefficient of x inside the sine function. So we're dividing by 2, and then plus c, all bounded by the points 3 and 8. Tidy this up a bit. Bounded by the points 3 and 8. Substituting these points, so we'll have 2 lots of 8 to the power 5 minus 4 sine 2 lots of 8, all minus 2 lots of 3 to the 5 minus 4 sine 2 lots of 3. Remember, you can calculate all this in one go. I'd recommend this, but if you haven't, this will be, which equals 65,050 to the nearest integer. For the part 2 questions, for this first question, we want to take out a numerical factor. In this case, it's 6. So we can take out a factor of 6, which is bounded by the points 2 and 1 still, and that leaves us 1 over x dx. Integrate 1 over x, looking at our table of derivatives, that will give us ln x. So we'll have 6 lots of ln x, bounded by the points 1 and 2. Substituting the points, so we'll have 6 lots of ln 2 minus ln 1. Enter that into your calculator, and that will give us an answer of 4.15883083, or 4.16 to 2 decimal places. Question 2 looks a bit trickier, probably because it is. Firstly, we want to take out a common numerical factor, which in this case is pi. So we'll have pi on the outside of the integral bounded between the points minus 2 and 4. And we're left with e to the x plus half cos x with respect to x. Integrate each term. So we'll have e to the x, which integrates to e to the x, plus cos of x integrates to sine of x. So we'll have half sine x, and then plus c, all bounded by the points -2 and 4. And don't forget that we are multiplying this by a constant, which in this case is pi. At this point you can substitute in the points, so we'll have pi lots of e to the 4 plus half sine 4 minus e to the -2 plus half sine -2. Enter all that into your calculator and you'll end up with 171.3395172 or 171.34 to 2 decimal places. This third question, we've got two terms. We want to take out a common numerical factor, which in this case is 4. So we'll have 4 lots of the integral bounded by the points 0 and 6, lots of sine 7t minus 3e to the 3t, all with respect to t. We can integrate it at this point. Well, sine 7t, we want to refer to this one here, which integrates to that. So actually it changes sign, so we'll have minus cos 7t, and then it'll be divided by that coefficient of t. So a seventh minus 3e to the 3t. We're looking at this one, and it's going to go backwards or integrate to this one. So the e to the 3t stays the same. However, this constant, we're going to divide by the coefficient of the power. So we'll have 3 divided by that 3 up here. And all this is being multiplied by 4 and bounded by the points 0 and 6. We're going to tidy this up a bit. And then we can substitute in those points. So we'll have 4 lots of minus a seventh cos 7 times 6 minus e to the 3 times 6 minus a seventh cos 7 times 0 minus e to the 3 times 0. Now I'm not going to work out all these individually because it'll be horrible. I'm just going to do all of this in one go. Enter it all into your calculator and you'll end up with minus 262,639,872 to the nearest integer. Or if it's to the nearest 3 significant figures, it will be minus 262 million.